Good evening, everyone. Please, can I be heard? Reaction, thumbs up, if I can be heard. Can I be heard? All right. Prince Anadahu, thank you very much. All right. So today, I don't know if we should wait a little while for the others to join, since we are Joshua. Let me enable your mic. Joshua.
Sorry, it's a mistake.
Okay. All right. Okay. So I don't know if I should wait for about 5 minutes for others to also join, since we are the class I'm hoping to teach today is not what I'm actually looking at. Probably a 5 minutes or three will do before we set off. Now, before they come in to join us, I would like to first carry out the information that we are going to have a little bit of practical at the end of or getting to the close of this section. And then I'm pleading that if you haven't yet set up your coding environment, you do that before we get there. Otherwise, you won't be able to follow with what we are about to do that much. And the practical is very, very important with respect to getting akin to the understanding of whatever we are doing. So please do make your setup of environment ready. All right. And I think 31 people just gone down to 30, but we can start with something before the rest join us. Um, so let's begin with something. Okay. Good evening once again. I'm your tutor Felix Freeman Asante, and I'm going to take you through section 1 of DCIT 104. All right. And then I hope my screen can be seen, because I'm currently sharing my screen. I hope my screen can be seen. If yes, please a thumbs up. Okay, thank you very much, friends, for the reaction. Let's proceed. So today we're going to look at the whole introduction to programming, what programming is, and so many other things. Let's look at the objectives that we are supposed to attain today at the end of today's lesson. So at the end of today's section, we are supposed to have certain things that we should be able to attain. All right. And then the first thing we should be able to attain is that we should be able to define the terminologies used in programming. Right, there are some certain terms that are used in the field of programming. No matter what programming language you are into or what programming environment you are using, there are certain terms that are generally accepted, all right, and recognized. And we are supposed to be able to know these terminologies and be able to what define, not only define, understand, all right. We should be able to understand what they even mean, all right. And then the second thing is that we should be able to explain the tasks performed by a programmer. All right, what are the tasks that a programmer performs? And then what is even before you can perform a task? Okay, there has to be a particular problem. All right, so what are some of the problems we face that kicks us to perform certain tasks? Okay, and then we're also supposed to understand the employment opportunities for us out there if you decide to go into programming or supposed to specialize yourself in the field of programming. What are some of the job opportunities out there? All right. And then we're also supposed to explain some history behind what programming languages. All right. We're going to get the understanding of certain fundamentals as to the history of programming language. Then we should, please, I can't present and then look at, so if anybody hands is up. Prince, Mr. Prince, Nana Dako, please, can you please notify me if somebody raises their hand for a question? Okay, I'll be really grateful if you can do that for me. Okay, let's proceed. All right, we are supposed to also explain certain terms like a sequence, selection, and repetition, as used in the field of coding. All right, as used in the coding discourse or coding environment. All right, what these particular words mean or stand for. And then we are supposed to write certain simple algorithms. Remember, just notice the fact that the sentence starts with write, all right, not actually code, all right. We are supposed to write certain simple algorithms. This is because algorithms are a set of instructions. They are not actually the code, okay. And then these algorithms are going to be based or being written on the user or the knowledge you acquire on what a sequence, a selection, and repetition is. Okay, just give me a moment. All right, thank you very much for your patience. So at the end of today's section, we should be able to attain these objectives. Okay, now let's start from programming a computer. All right. Now, it is important that to understand that the relationship between the terms programs, programmers, and programming language. All right, we have to understand what exists between the kind of relationship that exists between these three terms. All right, as we stated earlier, we are going to learn some terminologies and then their meaning and understand them. Okay, so what first of all, apart from what we are seeing on the screen here, who in his or own words be able to define what a program is? What a program is. If anybody can volunteer and then give us another perspective of what a, okay, let me Aqua, let me unmute your mic and then allow you to speak. Aqua, please, we are listening.
Good evening, sir.
Good evening.
Please, I think it's the way of writing computer solution to solve a problem, like writing a computer solution, yes, in the language the computer understands to solve a problem. Kind.
Okay. Okay. All right. That's very true. Anybody else with another submission for us? I am Joshua. I saw your hand up. Let me unmute you. Let me unmute your mic. Joshua, please, you can speak. Okay. Joshua. Joseph, sorry. The name is Joseph, sorry. Joseph. I have a friend called Joshua, so I'm sure he's with us right now.
Good evening.
Joseph, please.
Yes, please. Can you hear me?
Yes, please, I can hear you.
Can you recall the question for us?
Yeah. You want me to repeat the question?
I mean, record the question for us. Like,
I should record the section.
yeah,
Yeah,
we
asking
need
you to record the section.
yeah,
I don't really get you. Oh, okay, I should record the section. Oh, I'm sure that is being done by the team at the moment. Okay, thank you very much. And then I'm
Okay.
having also um, yeah, Joshua. Now I'm right. Joshua, please unmute your mic and speak.
Yeah. Thank you, Freeman.
Yeah.
So a program, we can say a program is a set of instructions.
Okay.
Yes, that tells the
It's
computer
a
what to do.
okay. Continue.
Yes, it's a set of instructions that tells the computer hardware what to do.
Okay, so it's a set of instructions that tell the computer how to function or what to
Hardware.
do. Okay,
Yes, out of
that's
yes, yeah, yeah.
all right. So anybody else? Let me take one last submission. Joshua, you can. Okay, thank you. Um, Anybody else, please? Okay, then let's proceed. We are moving really fast, but feel free to stop me at any point if you don't get the explanation of anything. Now, from what we are seeing on the screen, the programs, these are directions, all right, that we human beings, all right, give to computers, all right. Now, imagine if, for instance, somebody walks to you, all right, the person is going to a particular location. All the person knows is the name of the location, and then that individual walks to you and asks you, and since the person came to meet you, the person assumes, all right, that you know some one or two places around, or even if you don't know, you can direct that individual to somebody who does. Okay, so the person comes to you and says, I want to go here, all right, but I don't know how to get there. um can you please help me? Then the person who we are taking with the father, the person knows the place. Okay, so the person tells you, all right, take a left, take a right, take a left afterwards, and then go straight. You meet a signboard that says that is the place. Okay, now have you noticed that before you approach the individual, you knew nothing about how to get to your location? Yes, a computer knows how to, yes, put two things together. A computer knows that after I place this and this particular number together, I should get this. But if you do not give that computer the set of instructions, go left, go right, go, it will not know how to get to its destination. Do you understand? So computer needs to be instructed. They need to be. Otherwise, they won't be able to perform the task that is there. We can't assume that yes, it's a computer, it's able to process, do this, do this, do that. So we are all assuming that because it's able to do that, then it should be. Yes, the person can be able to walk to the location. The person can be able to pick a car to the location. That does not mean that he or she knows how to get there. All right. So you being the one instructing the individual on how to get to their location, you are like a program. Do you get what I'm saying? You are functioning in the shoes of a program. All right. Giving the fact that you are sorry, let me put this thing right. All right, the instructions you are giving to the individual are like programs. That's what I was saying, you are like a program. All right, but you, the individual giving the instruction, you tend to be the programmer. All right, let's try and get this concept very clearly. All right, I'm just trying to put it into that example that I just gave. All right, you are the one giving the individual the instructions. All right, so we are seeing the individual as though the person is a computer who is waiting for an instruction. Okay, good. Then the instructions you are giving to that individual is what we call as the program. All right, but as you are giving instructions to that individual, you have to speak in the understanding of the individual, and you do that using something called a programming language. Remember, this individual is a computer. All right, so you have to use a programming language to speak to that particular person, that the person will understand your instructions. Are we okay? So I'm just trying to get these whole three things together for you to understand at a go that programs are like their instructions that the computer runs on to be able to perform a particular task. Okay, in other words, let me just say that you don't expect to launch a camera app and make a phone call over there. Do you understand? Or take a picture and at the end of the day is calling somebody's number. All right, because at that place or at that particular program, all right, that has been created for the computer to work, it only functions giving access to the hardware component of as that's the camera, to be able to do certain recordings and certain things. That is the instruction given to that particular program. That's the set of written codes given to that particular program. So whenever you tap on that program or launch that particular program, it's going to follow that set of instructions. Are we okay? And then you being a programmer, you are the individual that understands this language to be able to send it to the computer, that the computer should say, okay, you are saying this, I should do this. You are a programmer. So the person who creates these directions is the programmer. Are you okay? So I'm telling you to take a left, take a right. I am being a programmer here. Do you understand? By you that I'm giving the instructions to, you are the, in a sense, a computer. And the instructions I am giving to you is the programming language. Please, I hope this concept has been well understood. If yes, I would like some 1 or 2 thumbs up so I know that yes, I can proceed. If a question to you can raise your hand. Let's take the question. Please, I really like us to react. Okay, yes, thank you very much, Aqua. I really like us to react. This helps me know that what I'm putting on board, you really get it. All right, otherwise I'll be like I'm talking to my screen. Do you get it? So please put down reactions if we do understand something. If not, let's raise our hand and then ask our question. All right, it's a class we are here to understand, so please let's do this together. Okay, now I think these 3 concepts has been well explained, so let's move on to the next one. Now let's look at the job. All right, let's look at the job, the program's job. What is the job of a programmer? All right, in case you are called a programmer, what do you do? Okay, so programmers help solve computer problems. All right, because you, one way or the other, have a way of interacting with the computer based on a particular language known as the programming language. As I stated in the example earlier, you have been able to solve the person's problem by giving the person directions to his or her location, or where he or she wants to get to. So because you, the programmer, understanding a programming language to give instructions to a computer, all right, because you are able to do that, then we declare you as being in the position to solve problems related to computers. Do you understand? So as a programmer, one of your jobs is that you should be able to solve problems related to computers. All right, good. And then employees and freelancing. All right, employees and freelancing, and this particular concept, I want your idea, I want your take on what you think this particular thing means. Then let me come in as well. All right, so I wish anybody could raise a hand and then give us his or her take on what employees and freelancing is. Anybody? Okay. Okay. Let's proceed. Let's proceed. So when we say employee, all right, when we say somebody is an employee, what are we trying to say? We are trying to say that the person, one way or the other, works for somebody. All right. You as a programmer, your job is to be a service to somebody. All right, you can't be a service to yourself. Even if you create a program, even if you say I'm sitting down to create a particular program, you create that program based on the problems of people and how the program is supposed to solve the problems of people. And one way or the other, you have been employed by the people to solve their problems. All right, so that is one of your job. It's one of your duties, all right? Unless you don't want to end out of what the knowledge you have. But if you want to use the knowledge you have to earn something, then one way or one best way of earning something out of your knowledge is to serve people. You understand? As a programmer, one of your job is to use your knowledge to try solve problems that are related with people. All right, create a program that will solve that problem, and by so doing, it's like as if you are in the shoes of being employed by the people. Do you understand? So that's the whole concept of it. All right. Then we have typical steps involved. Right. So you have to meet with the user to determine the problem. All right. First of all, there is no solution if there is no problem. Okay, let's put that one down. There is no solution if there is no problem. So a programmer first has to meet with whoever is having that problem. The person who came to you to seek for direction met with you. All right, the person had to come to you, put his or her grievances before you were able to what? To try and give the necessary instructions the person should follow to achieve a solution. All right, so there have to be a meet. All right, there have to be a meet between the two of you, or even some group of people and yourself. All right, or your team and them. all right, to first identify what the problem is. All right, then we convert the problem into a program. But one thing I want to put on board here is that as a programmer, everybody's problem is your problem. All right. Now, if I tell you that there's a saying that goes in our local, I don't know if I'm allowed to use it here, but they say that if it is affecting a friend or somebody and it's not you, then it's affecting a tree. Like, you get what the whole concept I'm trying to say. What I'm trying to say is that as a programmer, to first be able to solve somebody's problem efficiently, you have to put yourself in the person's shoes. Ask yourself certain questions like, if I was to be that individual facing this problem, what will I do to help myself as a programmer? You understand? That is how best you can be able to meet with changing that particular problem into a program. All right. If you don't do that, I promise you, they'll always end up calling you and say, please, this part is doing this part, because you didn't go all around seeking that if this was my problem, how will I help myself? Do you understand? So it's very important that as a programmer, you learn how to put yourself in the shoes of having the problem to be your own. Do you understand? That's how best you can be able to relate with solving it. Okay, then after putting down um, the problem into a program, that is a set of instructions, okay, then you have to test it. Now, the testing period, sometimes we call it piloting. You have to pilot the program, right, for a period of time. All right, you have to test the program, its weakness. Sometimes you even have to overdo it, push it to its limits and over, just to see if it will break. Do you understand? Or see the conditions that are there to break the program. Right. So this all goes into testing the program. And if God being so good, the program works out the way it's supposed to do, the way it's supposed to go in solving your problems, then we say that, wow, let's now provide a user manual. Right, let's provide a user manual. As you and I can say that it is not everybody, every individual that you put a computer in front of that will know how to operate it. We can all testify to that fact, but I do stand to be corrected. But you can put in a computer in front of somebody, all right, who has been to school, let me be specific, all right, and will know nothing of what even control plus C stands for. Right. So and remember, it's a computer. All right, you need to give it that set of instructions to follow. So if the individual wants something to be done on the computer with the program you have created on that computer, but that individual first of all does not know how to use a computer, that's the first thing. Secondly, does not even know how to operate the program on that computer, then it's like as if you are back to square one. So when you are creating a program for some group of people, you should target along with a user manual. And we can all testify to the fact that the first time you launch an application after downloading it for the first time, if it is on the phone, I'm trying to relate it with the fact that it's been on the phone, even sometimes on computers, all right, on machines, let me be specific. There, when you launch the application, there are some kind of like tips that pops up to every button, trying to tell you what to do. All right, that when you click on this button, it takes you to this place, it takes you to the dashboard, it refreshes the page, it takes you to this files. I hope like we can all relate with what I'm trying to say. After it's done, that all that kind of tips, giving you that kind of instructions, when you launch the program again, you are not going to see that. All right, Aqua has a question. Okay, you can relate with it. Thank you. So it's something that is like a user manual, all right, that tags along the program, because you can't provide it in the form of a sheet that the individual should go and read everything before coming to launch the program. All right, it does not work that way. So imagine I've launched Microsoft Team for the first time. You see some kind of something tagging around here telling me that, okay, when I click on this button, this is what it does. When I click on that button, that's what it does. You should be able to do that for the user of the program. Otherwise, don't expect them to know what is each button or each thing does in the program. So that's what I mean by providing a user manual to the program. Okay, now let's quickly go on. I think we spend enough time here. Now, what traits should a software developer have or possess? Okay, what are some of the things? When we say traits, these are things that are either inherited or either you inherit it or you learn it, all right, or you acquire it in life as you are moving on. Now, there are certain traits that you are supposed to have as a programmer, right, to be able to live successfully in the field of programming or in the environment of programming, all right, a software developer to be specific, all right. One of these skills, the first one, all right, is on the first one on this list is analytical skills. Now, when we say somebody is analytical, what does it mean? Like somebody should come along. Let's have a simple interaction. When you say somebody is analytical, I can see something in the chat. Okay, let me unmute you for you to speak. Okay, so it's just recording. All right, you have been unmuted. You can enable your mic and speak. Aqua.
And when you say someone is analytical, it's just like to be logical in reasoning.
Okay.
That's my
Okay,
perspective.
that's very deep. All right, anybody else? I don't know why I click understand. All right, let's hear from Steve as well. Steve, please, you can unmute your mic. Monica, why are you laughing?
Yeah.
All right,
So
Steve.
for someone to be analytical, I think you should be able to be someone who can deduce whatever problem it is, to make deductions of the problem to find solution.
Thank you. That's very, very true. That's also very, very true. All right. Thank you guys very much for your submission. All right. I really do appreciate your submission. All right. Now, they are all right in their own ways. All right. When we say somebody should have analytical skills, all right, this is a particular skills that involves a lot. All right. It does not only go with even just identifying and trying to solve it. It goes beyond what we actually do understand. And that's why I stated from the beginning that as a programmer or a software developer, you should be able to put yourself in whoever you are trying to solve his or her problem's shoes. Do you understand? If you find yourself in that situation, you yourself will know that yes, this is my problem now. What do I do about it? And if you realize that if you make this thing personal, there is some particular skill that comes along with that action you just did. All right, you start to think. That's the first thing. You start to question yourself. You raise certain questions to yourself. All right, what if this? What if that? What if the person does this? Okay, then what would I do? What if I'm faced this way? How would the program be able to solve or help me? What you are doing is what we call as critical thinking. I hope we are all following here. You have to be able to first put yourself in the person's shoes, identify the problem, appreciate the problem, think of the possible ways of solving it, and think of the possible ways it can go wrong and how to go about it when it does. You should think about all the possible outcomes. What you are doing in that state is that you are being analytical. All right, you are trying to find out everything related to the problem. Sometimes the problem might not even be the program. It can be who is using the program. Maybe you are supposed to clear this button before you clear this one. The person does not know. All right, you go and clear this one before you come and clear this one, and you come and tell you that it's not working. You understand? So you should make it user friendly, and all these thoughts goes into analyzing the problem. I hope you understand what I'm saying. I really hope you guys do appreciate it. Now, the next one is communication skills. All right. Now, how will you be able to communicate to whoever you are solving the problem? Remember, from the example I gave from the beginning, I initially gave that example. All right. You have to approach an individual, right? Let's look at the facts from your end, not even the individual who needs solutions to the problem, but you giving that individual some set of instructions to follow. All right, that use this road, go here, pick a taxi to this point. When you get here, you see a signboard. In case you don't see the signboard, ask people. You see this kind of action going on between you and a person. We all know that communication is the exchange of ideas, the exchange of knowledge, and that is what is going on. All right, you are giving your knowledge or your idea or whatever you have to that individual in an understandable way. And as a programmer, you should possess that trait. You should be able to communicate to your customers how the problem came about, first of all, the ways to which you came about in solving the problem, and then how this program is going to help them personally and as a group. All right, because in certain field like where I work, for instance, that we have a different software for uploading children's report and things when we are in school. All right, and then we have a different software to do that when we are home. So you can see the whole concept of the fact being that in school we have certain machines that are available, and the programmer kind of created a software that is able to run, giving us certain kind of special features on their machine, and then created one for us, knowing that it's not each and every one of we the teachers that have machines in our homes. So created one for us on phones, and this particular one works in a particular way that makes even the usage of it better and nicer on phones. That's why I said that you should be able to communicate with them on how to use this program to solve their problems as a group and individually as well. All right, then you should also have customer service skills. This one, I will vow that even myself, this trait, I'm still working on it. The reason being that nipa be hard doing. All right, why am I saying that? You create a program for some company, give them the user manual, teach them, even go to the extent of going to the company, having a kind of a meeting with them, teaching them that this is what you are supposed to do in case you want to do this. And then at the end of the day, the kind of cause that will come. Me about to remember, yes, I am. On the data. You go and check, the person has not even turned on the data. You see, and these things really bother. You are one way or the other trying to find out how to solve all their problems, but you get to go deep down inside and you realize that, Charlie, this thing is not my problem. This one is not for my code or my program that I've written for them. This is an individual, only data, right? Even though this or has some but only data. You get it? And it's a problem that we programmers we face. So if you don't have this patience, all right, of dealing with customers, if you don't have this patience of dealing with customers, all right, then you are going to sorry to say, you are going to find it difficult. Sometimes they can call me, I pick up the call and I sleep, because the time they'll call you and you should be available. Try, let me not put that, but try to be available for them as much as you can, because you are being paid for that services. Do you understand? Your services does not end on delivering the program to them. Your services ends when the person is able to successfully use the program to achieve the goal. So any point at which the person is not able to do that, you are the first point of call. All right, you will be the first because you wrote the program. You understand what you have written. I hope we understand that as well. So it's very important we understand that. Okay, then let's also go to you should be detail oriented. All right, for the purpose of being at a position where you not find yourself wanting, like, being thrown questions to, like, you didn't tell us that this is what will happen when we refresh our page, that everything that we have inputted, if we didn't save it, it will disappear. You see this kind of questions, they will tell you, like, and don't expect them, they are right, don't expect them to know. Right? Imagine if I'm doing a user input, okay, or in a program, like my children. This person had 2, this person had 3, 30/4. Sorry, 30/4 they have. 4/30, okay, and then all right. I input everything, and then I say, oh, sorry, I want to go and use the washroom and come back. Then when I quickly use the washroom and come back, I realized that there was a short power outage, and then the computer came back on. We all know how computers work. Are we okay? But some people are thinking that you created a program to do something called autosave. That's what the person will tell you. Oh, I thought it was autosave. Because the last time I was using some particular program, when I type it, I can even go and come. My phone will even go off and come. When I go there, so you have to tell the individual, be point blank, and tell you that I don't know what you have been using out there, but for my program that I've created for you, this is what it's able to, this is its capabilities, this is its limits. You should be detailed, all right, so that they don't throw certain questions at you that you find yourself on, that you didn't tell me, I didn't know. All right, so these are some of the traits you're also supposed to have. And again, you should have a problem solving skill. That one is very, very important. All right. They call you, hello, I've tried to do this, it is not working. I've tried to do this, it's not working. Open it at your end. And then let the person tell you what he or she is trying to do. Okay, what are you trying to do? Okay, I'm trying to do this. You are solving the person's problem at that moment. What did you input here? Oh, I did this, I did. Okay, this is the reason why it's not working. Because you are doing this, you are doing that, you are doing that. All right. And to be able to do that, you should be able to have customer service skills. You should be there for the individual before you can solve the problem of that individual. All right. And then a programmer should not, I don't see any very good programmer who can learn all the different programming languages very well. Even if there is, all right, the person can't read, the person is as good as he or she is in one particular programming language. All right. So you should have a team. You should have a team that you work with. As a programmer, you should have a team. All right. There's somebody doing a little bit of back end, front end, data store, data analysis, and all right. You should have a team. All right. It's very, very important. And you should know how to work with team people. You should know how to work with your team to be able to achieve the goals that you have set. All right. That is very, very also important. So you should have team spirit. Right? You should have a team like spirit. You shouldn't be I'm solo, right? I'm always solo. No, it will never work out. Okay, it won't work out. Then you should have technical skills. The technical skills is a bit dicey in a way that when we say something is technical, all right, it means that it demands physical attention to. All right, this is, bear in mind, the program is a set of instructions you are giving to the computer, all right, to run. But what if the computer is not able to run your program? You should know that the hardware components requirements of your computer maybe is not meeting the program, or the program is not meeting. You should know all this. You understand? So you should have some kind of technical skills. You should have some kind of technical knowledge on hardware components. Don't be like only software. And put this in mind too. Your software goes a long way to work together with the hardware to be able to work. So you should acquire this knowledge about the technical aspect as well. But don't just be like, oh, my own is just code. No, your own is not just to code. Trust me, you should have the knowledge on this hardware components as well. Okay, you should have the knowledge that your computer is able to run on this operating system, is supposed to do this. You should know all this. All right. And if you know all this, you can be able to communicate it as well, so that they don't come and tell you, I'm opening it on my phone, it's not working. Let the person know that it does not work on phones. It works on only computers for the meantime. All right, that's what you're supposed to do. Now let's look at some of the employment opportunities. But so far so good, right? Anybody with a question? Let me quickly see if anybody has a question. Okay, I see no hands there. Let's proceed. So let's look at the employment opportunities out there. So computer software engineer, all right. So you'll be having the opportunity of being a computer software engineer. All right, that is you come about creating softwares, okay, software that run on computer. That's why they say computer software. All right. So you engineer softwares that are able to run on computers, okay. All right. Then you should also be a computer programmer. All right, a computer programmer, you are the one working with the actual codes. Okay, you are the one actually inputting the set of instructions. Okay, as well. Okay, you should be able to code to the computer. All right, and these are people, companies are out there looking for people like this. All right, and we have a junior developer, senior developer, and all. You don't even have to be the best, right? Junior developer is like, certain codes like HTML, CSS, JavaScript. Even if you immediately hit JavaScript, you have entered another level of developer. Not even talk about knowing React, all right, and all these other codes. If you come to understand and know how these codes or these programming languages are used, all right, you become an asset to them. All right, so they sometimes pick up these junior developers who know this HTML, CSS, and then put them in the field, give them challenging tasks that will require them to broaden their language, and later on end up being senior developers and owing their loyalty to the company, because they picked them when they were not really that good. All right, so they are really, really interested in junior developers. So it's not an end hope if you are even starting to learn how to code now. Okay, it's not really that. Then coding is the process of translating the computer solution into a language that the computer can understand. This part I want us to really digest, break it down. All right. Now, coding is the process of translating a computer solution into a language computer can understand. All right. So when you sit behind your machine and you are typing, all right, what you are doing is that in your coding environment, what you are doing is that you are communicating with the computer. You are giving, we are kind of like communicating with the computer. That's why at the end of the day, when you run your code, you want the computer to also tell you something. All right. That's how communication works. Right. You want the computer to also give you a certain kind of desired feedback based on what the instructions you gave. So this kind of thing is what we term as communication. All right. So it's like you are communicating to the computer using a language the computer can be able to relate to or understand. All right. And this one is also a very key thing. People, it's a job, all right? It's a job opportunity. When they ask you what do you do, you can say I'm a coder, all right? So it's also there, all right? Some positions call for both engineering and programming, all right? And bear in mind, these things, as a software engineer and a programmer, they are two different things, all right? They are two different things altogether. They are not the same things, all right? To engineer something is different from programming it, all right? To engineer something is different from programming it. So there are some positions that demand that you should be able to know these two and how to go about these two. All right. So somebody can specialize in just software engineering. Somebody too can also specialize in software development. That is the programming itself. You understand? So these are some job opportunities that are there out for you. Now, from DCIT 101, if I'm right, and if most of us or all of us were inside that particular lectures, we learned that computers have a particular kind of a language that they are able to understand. That is zeros and ones, what we all agree to as to be binary codes. All right. Yes, this is the only language the computer is able to relate to. All right. Then, as you, the programmer, we are not going to type in binary codes. All right. But first, let me be quite clear. There's a history behind programming. All right. There's a history behind. If you can look at the arrangement of these particular languages, there is machine language. That's what we call as the binary code, the one that the machine actually and directly understands. All right. Then there is assembly language. All right. This language was written, all right, and converted into machine language using something called an assembler. All right. And assembly language, we can all relate to the fact from DCIT 101 is the use of certain mnemonics, all right, certain kind of words, all right, that has been specifically coded in a particular pattern of zeros and ones to perform the code. And an example was it being used in Scratch. All right, that's in the child kind of like picks up a kind of block of codes to arrange to perform a particular task. All right, and these codes have certain labels on it. All right, so this is like an assembly language. All right, then we have a high level procedure oriented languages. Then we have a high level object oriented. So there are two types of orientation going on here as coding is to be considered. All right, object oriented languages are different from procedure oriented languages. All right, so we should appreciate that they are set up. You can go out and do more of your research. I don't know if anybody can help us with some examples of object oriented languages, all right, and then some procedure oriented languages as well. But as far as we know, we can group them as one and say they are high level languages, all right. We have JavaScript, we have Python, and all. They all have a particular orientation they use, as in what they do, all right, what they are able to do. All right, we know of HTML, CSS, Python, JavaScript, C++, and all these coding languages are out there. But there are some that are specifically to give the computer certain procedures to follow, and there are some that actually work with objects on the screen. All right, they relate. Like for instance, we know HTML to be skeleton of coding. That's where we get our text, our headers, and all the text appearing. But for buttons and things, we work with C++ to be able to do. And then for the reactions that are the computer is, I want to put my cursor on it, it tells me raise your hand into parentheses, control plus. You see, this kind of interaction the computer is having with me also comes from JavaScript. All right, so you see that they are all performing different tasks. So they, even though they are all high level languages, they all have a particular orientation that they fall under. Okay, but generally, if they ask you to give some examples of high level languages, you can combine this and then give. All right, I've never seen a question that specifies that you should give the difference between the two. All right, but you can go ahead and do more research. Since I didn't really get any hand, or is any somebody's hand? Nobody. All right, let's proceed then. Okay, so now let's look at machine languages. All right, this is the first this is the languages that was first used by programmers. All right, and as far as I know, if you knew machine language, and if you are somebody who could sit down and then actually write machine language, then you are a veteran. Sorry to, I don't know if that word is like, we are boss. That's what I'm trying to say. You are something, right? Because to be able to directly speak with a machine, then you are and it required a lot of skill. All right, and somebody who had this knowledge back in those times, and even now, you will be very 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 valuable to the field of coding, all right, or to society, to be able to directly speak to machines because you know their language. We have tried to learn them binary code, but as far as we have gone as far as learning numbers and how they are converted to binary, and but we haven't gone, like, if I ask you to give me a whole sentence in binary, you have to go to I think it's called the ASCII, then you try and convert the letters and symbols inside to it, and it's a whole lot. You see, you have gone to a particular table to do that, but somebody back in those days knew it, that A is this, capital A is this, and the person was able to write it. As the person is writing, you see that the person is typing just zeros, couple of zeros and one, but behind it, the person is talking to a computer by actually typing a sentence, right? So those kind of languages, or that language, it really entailed a lot to be able to learn it, right? Programming in machine language, serious, all right, and error prone, requires highly trained programmers. You can see it right here, all right. It required a highly trained programmer to be able to code in that. That's why I said that if you are able to do this as of even this era, then you really be an asset, all right. You really be something. Okay, so back in those times, they have to go to school, learn and learn. Like there was a whole lot that went into that. And then let's come to assembly language. All right, and I said that assembly language made writing code simpler. All right. Remember, it's being compared to machine language. That does not mean it was the simplest. It is the simplest. All right. It's being compared to something. So it's being compared to the zeros and ones. That's the machine language. Are we okay? So compared to the machine language, these ones were much simpler. It made use of what we call as the mnemonics, right? These are symbols used to represent the actual machine languages or instructions. So this whole zeros and ones was being represented with this word. All right. So whenever you see this word, you know that it is this entire thing. I think this one was much more better, all right, in terms of learning and an understanding, more than actually getting to acquire the knowledge about all this. Are we okay? And it's quite obvious why, the reasons to why. Now, assembly languages, all right, require something called an assembler, all right, to be able to convert whatever you are writing, this one, all right, this mnemonics, back into what we call as the machine code, or the machine language, for the machine to be able to understand what you are saying. All right. Now, then another feature of it is that it is easier to write programs in assembly language. I think we have also looked at, even though it was easy, but it was still tedious and required highly trained programmers as well. Are we okay? It really required highly trained programmers to be able to use these languages. Now, the one that we have gotten to, all right, is the high level languages. And if you look closely here, you get to realize that in this particular part of it, they didn't really separate it that much, as in separate an entire topic by saying procedure oriented object. They just said high level languages. Okay, and under is then they did this kind of like detailed explanation of what they are. Now, when writing a procedure oriented program, all right, the programmer concentrate on the major tasks that the program needs to perform. So this is what we mean by the word procedure oriented. All right, as I was stating, trying to use the JavaScript and the CSS and then the HTML. All right, when it comes to CSS aspect, all right, that is the whole part where most of the time, or the C, you can even see here, there's one code called C, coding language called C, basic, and then COBOL. All right, these ones actually focus on what the program is supposed to do at the end of the day. All right, at the end of the day, you are supposed to do this, achieve this, put this and this one together, do this way, and these are the languages that follow that particular trend. If you want to focus more on procedure oriented program, you should try and look at these languages in your free time. All right, and then object oriented, and this requires that a program focuses on the objects that the program can use to accomplish its goal. So what are some of the objects that are on the screen right now as I'm displaying the slide? See, there's a this button, there is this button, there is this profile button, there is this three dots here. All these things are objects on the screen that help us to achieve what we want to achieve with our program at the end of the day. So you can see C++ going on here. You can see visual basic. The word visual even should tell you that it works on what we are seeing. All right, as I right click, there are some buttons here and all that appear. All right, these are all available because of object oriented what. You can see Java and you can see C sharp, or I don't know how they really, but I think it's called C sharp also. All right, so this is some examples of, or the difference that exists between procedure oriented and object oriented programming. I don't know if I'm taking you too fast and anybody has any question to ask at this point. Joshua. Joshua, why? Joshua, why?
Oh yeah, I didn't get the last part too.
All right, let me take it. I'm saying that when it comes to high level languages, it comes in two folds. All right, that's the object oriented and then procedure oriented. All right, and the difference between them is that procedure, as its name says, focuses on what the program is supposed to do. All right, and then the procedures needed for the computer to be the program to be able to perform that task. All right. Good. And then the object oriented focuses more on the interface. All right, what's the buttons or the objects available for the user to use to be able to perform that task. Like, I hope you get that concept, that the differences.
Yeah.
All right, so now we are going to look at something called control structure. All right, this is where the whole program starts to get interesting and a bit intense. All right, so let's try and catch up and follow. All right, it's really interesting starting from this point. All right, we've done a lot of talking, but I think starting from here, certain kind of practical will start to come inside. All right, so let's really try and follow what we are doing. All right, so now let's look at control structure. When we say a control structure or control structures, what are we talking about? All right, we are saying that all computer programs are written using one or two or even all these three. All right, one or more, two, three, or these three control structures, and they are sequence, repetition, and selection. All right, me, as being already in the field of code, there is never a time that I've gone without using any of these control structures. All right, I mostly use all of them. All right, based on what I'm doing. Okay, so let's try and get the understanding. All right, another term used for control structure is logic structure. Please don't forget that it may be asked in objectives. Right, so in case you see logic structure or control structure, it's the same thing. All right, because they control the logic flow of the program. That's why sometimes it is called a logic structure. Okay, now all right, so in any program that is written in sequence structure will be used in most. All right, so what this is trying to say is that every program, all right, that we write, there's a tendency that we are going to use all these control structures. All right, we are going to make use of all these control structures. So let's look at them and really appreciate them. When we say something is sequential, all right, anybody have an idea when we say something should follow a particular sequence, all right, or as in terms of structure, anybody can help us when we say something should follow a sequence, or there's a sequence of events or something. Anybody?
I think uniformity.
All right, so uniformity. Okay, any other? Thank you very much for your submission. Any other? Okay, Bright's hand is up, so let me unmute. Right, allow my Bright, please, you can speak.
Good evening. It follows a particular order, like one after the other. So
all right, so you should follow.
Yes, a particular order. Yes.
Okay, you should follow a particular order. Okay, any other? Maybe the last one before we proceed. Aqua, your mic is already unmuted, so you can.
Oh, okay. So, a set of related things or items that follow each other in a particular way.
Okay, I like the fact that you use the word related. That's also a very powerful submission. Thank you very much. All right, let's go on then. Let's look at what we have here and then what you said. All right, and then let's try and merge both of them together. All right, now when we say a sequential structure or a sequence structure, this directs the computer to process the program instructions one after another in the order in which they are listed in the program. In other words, behind the program, as in the code. All right, that's how codes are executed. They are executed in sequence. All right, and one fascinating thing about it is that one way or the other, even if it is not sequence, as in this one executes, goes and pick this one later and does the reason why it's able to do that is because they are related to each other. So I really like the whole concept of the fact that our friend brought about our mate brought about the fact that they should be related, right? So you'll be like, so why is it that I picked up the S, then later on it does not really matter, right? If you look at the logic behind it, remember, these whole structures are called logic structures, all right? Because they determine or they tell the logic flow of how the program should be executing. Okay, so one of these logic structures is that it must be, the program must be run in a particular manner. All right, that will make sense. That's the whole concept of logic. Okay, so when you are typing your code in C++, because that's what we are doing now, I want to use that one. All right, and then you call out the computer to see out something, or let me put it, to see in something, or you ask the user to input something so that it's stored somewhere, and you have been created that store somewhere already before you are asking the user to input. Then I wonder, when the user inputs, where is it going to be stored? Are we okay? So this particular sequence must be placed into consideration before you even type. That's why there's even a need for algorithms. We will get there. Okay, it's even here. And they say that an algorithm is a finite, not infinite. Please, let's appreciate the word finite. All right, it means it has a beginning and definitely has an end. Okay, no program is able to run forever. As in the Alan Turing, as in I'm sure you guys do remember. All right, there's no infinite set of coding. All right, at certain point it has to come to an end. Even if the program decides to run forever, there's a particular limit that will be given to it, as in your capability or the storage capability of your computer. If it hits that limit, that is it. All right, it can't go any further. Are you okay? So this is a set of finite. All right, this is a finite number of step-by-step instructions. Let's appreciate every single word here. Step-by-step instructions that accomplish a task. Remember, they accomplish a task. They don't really go about solving the actual program, the problem. All right. This particular set of instructions are mostly written on paper. All right. This is an algorithm. All right. An algorithm is a step. Okay. After, how do I prepare banku? Okay. How do I prepare banku? First of all, I need the things, the fuel. All right, let me put it that way. The charcoal, and then I'll put the charcoal in. Somebody will be like, pick up the pan. pour this in. But so after you are done pouring all these things inside and mixing everything together, what are you going to do? You see, so there are certain kind of step-by-step way to accomplish something, and the fact that you are able to pen these things down or write them down, what you are doing is an algorithm. It really helps. It helps you know what you are doing. It works something like a flow chart. It works something like a flow chart. All right. So after this, let me do this. After this, let me do this. Then I end what I'm doing because I've been able to accomplish the task I want to. You understand? So that's what an algorithm is like. Remember, an algorithm is not the actual code. Are we okay? So this is a perfect example. Let me try and zoom in here. This is a perfect example of what an algorithm is. All right, let's look at it here. So we said I get this is I get one head, one body, one right arm. So you see, it's telling you this is like it's giving you a set of step-by-step instructions. All right, and when you get all these things, all these items available, you attach the head to the top of the body, attach the leg. You see, so I hope you all appreciate or you all understand what I'm trying to say here. All right, so that's what an algorithm is. Okay, now let's look at the next sequential, the next control structure. The next control structure is selection structure. Now this one is where everything really gets interesting. All right, what am I trying to say? This one normally does with the if else statements. All right, we all agree to the fact that even though there are some codes that are every code is written, all right, but it's not every individual that is allowed to use the program. And if every individual is allowed to use the program, all individuals are not the same. All right, in case I ask somebody what is your name, what is your gender, all right, and then the person inputs male, somebody else will also come to use that program and input female. Somebody can also come and use that program and input transgender. Do you understand? So a selection structure is a way of writing your code in such a way that based on certain conditions, all right, the computer executes the code based on certain conditions. If these conditions are met, run this. If that condition is not met, run this rather. And if none of them is met, then please return to the user that maybe user input error or do you understand, or invalid input or something. So we all agree to the fact that not every line of code will be executed when it comes to selection structure. All right, certain line of code will be ignored like as if you never typed them based on the fact that they don't meet a certain condition. And I like the fact that when this guy was explaining what a selection structure, it plays this thing in something called a parenthesis, this one. All right, and that's how in the coding environment we declare a condition. All right, we declare the condition in something called a parenthesis. When you declare the condition and the computer runs and gets to that line of code, and realize that based on the user input, all these conditions are met, then I'm running that particular line of code. All right, and then the rest, because it does not meet that condition, I ignore it. So that's what selection structure is. It does not really run the entire code, but it selects some part of the code to run normally based on what we call as user inputs. Okay, so let's try and read it here. The selection structure directs the computer to make a decision, evaluate a condition, all right, and then take an appropriate action based upon that decision. Right, the selection structure allows the programmer to evaluate data, therefore properly controlling the logic flow of the program. Another name for selection structure is the decision structure. So we all understand the fact that it is known as the decision structure. All right. So if you be like in your code, you be like if gender is equal to male and this is equal to male, then tell the user this. Right. So when the user inputs gender and says male and age and says maybe 25, then the particular kind of line of code should be selected and executed for the user, and the rest should be ignored. Do you understand? So that's what selection structure really talks about. I don't know if anybody has a question about that. Any question? Any question? Okay, no question. Let's proceed. All right, so an example of a selection structure is what we are having here. All right, let's zoom in and then look at it. Now you can see that as I stated earlier, it really comes with using if and else. All right, bear in mind this is not the actual code. This is like an algorithm. Okay, all right, this is like an algorithm written on paper. Now they say that first approach the railway, railroad crossing. That's what the car has done. All right. So if the first of all, the condition that if the crossing signal is on, this one, crossing signal, all right, if that one is on, then this particular code or this kind of instruction here should be run. If not, then because this condition inside this parenthesis was not met, then the computer ignores this code like as if you didn't even type it in the first place. All right, and then select something else that meets the condition. I hope we really understand what selection structure does. Any hands? Okay. Silence means consent. Then let's proceed. It means everybody understands it. But please, let's try and then get questions coming. Okay, it really helps our section. Okay, I don't know. I can zoom out. Let me try and zoom in. Okay, let's continue. Now, this is another selection structure. Okay, you see, it's really working with if and else over here. Don't worry, we will get the chance to play with these ones when we I just wanted to understand the logic behind it or the whole concept of it. Now we have the repetition structure, and that's the last structure, mostly not used based on certain conditions as well. So now let's really look at it. Let me give you a live scenario before I really go into explaining. Now look at this. Imagine if you launch a program, all right, and then the program is asking you to input your email, and then first of all, the input you give does not meet any standard of any email out there in this world, whether Google, Yahoo, even the ones given to us by the school, or it does not meet any standard. What do you think the computer will do again? Anybody? What do you think the computer will ask you to do again? I'll start mentioning names. So.
It will ask you to try again.
It will ask you to try again, and then the process of the computer asking you to try again, what name will you give to that? If you are being asked to do something again, what are you doing?
Repeat.
You are
Repetition.
repeating it. Thank you very much. So that is when that one actually comes into play. I think somebody has the hand up. Let me unmute you. So Vida, please you can unmute and speak.
Yeah, so I just want to say repetition.
Good. So that is it. So this is a set of code. It is sometimes called looping or iteration. All right. This also sometimes is based on conditions. You see, you can see that the condition may be checked at the beginning or the end of the set of instructions. All right. And if these conditions are not met, then you are going to ask the user to try again. All right. So any program that provides you with the whole concept of you trying again, what is actually going behind the code that is actually going on behind the program or the nice interface you are seeing is a repetition structure. Why? Because if you are not meeting the particular condition that has been set by that particular part of the code before it will allow you to put, like for instance, your password. Don't expect for your phone to open if you keep on entering a wrong password. Do you understand? It will ask you to keep on trying and trying and trying again until you get it right. So that's the whole repetition structure. And then in C++, you look at it in using whiles and all. You really enjoy it when we also get to there. All right. Let's quickly proceed. We don't have much time. But anybody has a question before we go on? You can raise your hand and ask. Okay, Vida, your mic is already unmuted. So.
Yeah, please. So I want you to elaborate on the looping.
Okay.
Yeah.
All right. Let me really throw more light on it. Okay. So when we say something is looping, all right, it means that the thing then one way or the other repeats a particular event from where it started from. All right, so let's kind of read what has been written here. So looping or iteration directs the computer to repeat one or more program instruction until a particular condition is met. So by that, please let's understand the fact that until you meet that condition that has been set in the set of code instructions that has been provided by the programmer, that the program is running on, until you meet that condition, my dear, that particular action will be looped over and over and over. The only way that loop will break is when you meet the particular condition that has been set. Do you really understand what I'm saying?
Yes, please. Yes.
Good. So
Thank you.
looping only comes in place with conditions attached to it. Right? If you don't meet those conditions, don't expect to proceed. It won't work. You have to try again until that particular condition is met. Imagine if, for instance, you typed your password using the first input to be a capital, maybe V. All right, I'm using your name as an example. And then
Yeah.
upon typing it, you didn't know that your caps lock key was on. And if the caps lock key is on, you know that every input you are going to give as a letter will return as a capital letter, right?
Yes,
And you
please.
keep on typing, and you said, I have typed Vida, I have typed it. That's this VID, I've typed it, but why isn't it working? Why isn't it working? Why isn't it working? And I'm sure that the reason behind it is quite clear. And why the action is being looped over and over again to ask you for your password over and over, even though you are entering that name, or sorry, the name, so it's quite also clear. Are we okay?
Yes, please.
Good. So this is very, very important that we really understand that. Okay. So that's what looping actually what does.
Thank you.
Carly, please. Asking for control. Okay, I think it's here. First. All right, let's proceed. Let's proceed. All right, we are almost done with the whole concept of the slides. All right. There's not really much, but everybody gets what we mean by looping something. Okay, so let's try and look at the kind of example given here. All right. So original algorithm, remember, this is not an actual code. All right, this is like something you have written. All right, that makes sense. All right, step by step instructions. All right, so they say walk forward. If Ginger is on bench, gently shove Ginger off the bench. And if, all right, turn left 90 degrees, sit down on the bench. Now, this thing can be modified. Now, when it comes to repetition, I'll go back to that one too as well. But that's that the other aspect of repetition is what this has spoken about. All right, it comes into two things: you, the one writing the code, and the user also trying to meet a particular condition. All right, the slide explained the condition aspect being met, but you gave an example of the other aspects as well. The other aspect is that there are certain line of codes that you can repeat that can be simplified. All right, that's what repetition is. It can be simplified. That structure can be simplified in such a way that it makes your code more simpler and not too cumbersome. Like it does not have a whole lot of everything together. Look at how we have reduced 6 lines of code to 4. All right, just by putting repeat 2 times, walk forward. You see, we have simplified it. All right, we have simplified the code instead of having it being repeated over and over again. So this talks about you, the coder itself, like what you are doing at your coding environment. Okay, so this actually talks about that. And in this form, I will say that repetition is not good. Okay, when it comes to this, I'll say repetition of code of lines that actually or literally perform the same function where you can merge together as one is not really the best. Okay, try and make it one. Okay, if possible, try and make it one. All right. So that is that. That is that for repetition. Any questions? We are done. Like we are almost killing the entire thing. You can see that all that is left is summary, and then a certain kind of, I don't know if it's work, all right, labs for us to look at. Okay, we are actually done with what we are supposed to do. I just want questions to flow in if there is any before we proceed. No questions. Okay, so far no questions. Okay, then let's try and then quickly wrap up and then look at something now. In our next session, we will have a few, all right, of data types. All right, I think that will be our next section. We are going to look at data types. We are going to look at how to name, declare variables and constants and all. It's really an interesting thing to know. All right, so you can try your hands on these labs. All right, in our next meeting, you can bring forth your questions. All right, and as we go on, so let's try and summarize everything we have done here before we proceed. Now we've talked about we spent time to talk about this as a summary. So let's say programs are step-by-step instructions that tell the computer how to perform a task. And programmers use programming language, all right, to communicate with the computer. The first programming language were machine language, which were the zeros and ones, all right, and still the machine language is what the computer understands. And then we came forward to use of the assembly language. We needed the use of mnemonics and then an assembler. All right, then we came to the high level languages. All right, some of these high level languages make use of other things to be able to change this language into the one that is understandable by the computer, which is the machine language. Okay, and for C++, we make use of something called a compiler. Do you understand? So this compiler tries to convert whatever you type to the one that is understandable by the machine. All right, I think I've looked at here. Okay, yes. Now let's go on here. So we said an algorithm is a finite, all right? Bear in mind the keyword finite. It's very, very important that we know that it's not infinite, all right? It's finite. It has a beginning and an end. Number of step-by-step instructions that are written, all right? I'll put it that way. Let me be specific. That are written to help you when you are coding in order to be able to accomplish the task that you want to accomplish, all right, with the program. All right, then algorithms utilize three basic structures. That is the control structures, or what we call as the logic structures. All right, and these are them: the sequence structures and selection and then repetition structures. All right, these are the structures. Now the sequence structures direct the computer to process the program instructions in a particular given order, or one after the other. Okay, so that is that. And then the selection structures direct the computer to make decisions or evaluate certain conditions. And if those conditions are met, then that part of code should be selected and executed. Okay. If that condition is not met, ignore the code. It's as simple as that. All right. And repetition makes use of what we call as looping. All right. That if a particular condition is not met, keep on repeating this particular code or loop it until that particular condition is met. If it is met, then move on. All right. So that is, I have a couple of questions to ask, and if you can answer, you raise your hand and I allow you to answer. All right. So my first question is, all right, we are all programmers here. All right. So as long as you're in this class, okay. Monica has a question. I know. Monica.
It was a mistake.
I knew it. Okay, it was a mistake. All right, let's continue. All right, so my first question would be that as a programmer, all right, out there trying to solve people's problem, all right, what is one trait that should be part of your life as a programmer? Who can give me one? If you can give me more than one, so I really do appreciate that. Okay, your mic is already enabled, so you can.
Detail oriented.
Oh, you should be detail oriented. Aqua, your answer.
It should be creative.
Creative. Okay, Joshua.
You should be ready to work.
Should have communication skills.
Yes. So all these are traits. Okay. Now, my question is actually built on this one. This one that you just answered. Okay. So does it mean that if as a programmer you lack any of these traits, you don't qualify to be a programmer? Who can answer that for me?
No.
Why?
I think you can.
Please, I don't know. The
my
question,
answer.
please, the question again.
I'm saying that we all heard our colleagues give answers to the first question, that the traits that a programmer is supposed to possess, right? And I'm saying that if you lack any of these traits, all right, does it mean that you don't qualify to be a programmer? Okay, we have Ebenezer Nyako. Let me enable. At this point, I think I should enable everybody's mic. I don't know where that one is done. That's my audio settings. Anyway, I hope you get the question.
So if I clearly get your question, does it mean that if you lack one or all of them?
Good.
I'm
That is
saying-
what I wanted to ask.
I'm saying if you should lack any of these traits, does it mean that you don't qualify to be a programmer?
You qualify.
No.
Why? Why? Then the why question comes in.
Okay, so the lady should answer first, then I'll go with my.
Hey,
I am saying you still qualify.
where's my mic?
Well, I will say yes or no.
you can't have both sides of the coin. Stand on one side. Let's go.
Akwa is saying you
Yes,
qualify.
yes.
So, okay, all those in favor of you qualify. For now, just raise your hand. Let me see. Let me see the number of people saying you qualify. Wow, so far I have 7. Let's go. Let me see if there is more. Let me go. I'm supposed to look at people. Right. Let's see how many of you have your hands raised. Okay, so far 7. 7 is with the facts fervently saying that, hey, how is this number reducing? Come on, don't do that. Please stand by your decision. All right. Stand by your decision. So okay. So now I accept the fact that I have 5 people saying that you still qualify to be a programmer if you lack any of these traits. Okay, fine. You can put your hand down. And all those in favor of you, if you lose any of these traits, you don't qualify. Show by hand.
Boss, if anyone, we were 5, so the rest, they say you don't qualify automatically.
All right. Yes. The truth is that if you lack any of these traits, you will still be qualified as a programmer. The reason being is that let me give you the reason. The reason being is that one of these traits is that you should be able to work together with people. All right. You should be able to work together with people. And if you lack communication skills together with people, there is somebody who inside that togetherness or teamwork should be able to have them. All right. And it can never be that all of you lack communication skills. Do you get what I'm trying to say? So the fact that you don't have that ability, that trait can be found in some. And I stated earlier that as a programmer, these traits are not something you are born or you are initially born with. All right. You pick them alongside as you are in the profession. So it is not the basis of you being a programmer, but you being a programmer requires that you should try and acquire these traits. But this trait does not define you as a programmer. You understand what I'm saying? Okay, all right. Thank you very much. Now, the last question I'll ask, all right, is coming from here. We'll go up. Okay, it's coming from here. And my question is going to be that when we say somebody or an individual, all right, knows a programming language, does that make the person a programmer?
No.
By that. All right. Please, why?
So anybody at all can know a programming language without being a programmer.
Okay. Anybody? Any other?
She didn't explain.
She, Was I the same thing at Cherry?
One church.
How do I even explain it? Okay, so let's say me in person. Maybe I know programming language. Like, yeah, maybe I've read about those things, so I know them. But how to program, like, I don't know anything about it. You see, yes, that's what I have.
Okay, Ebenezer, Steve, let me, okay, your mic is already enabled. You can speak.
Yeah, so knowing a programming language is one thing, but making it functional, making it work is another thing. So for someone who knows it, yeah, you can know it, but to make a programming language work for you to solve a problem is another thing.
Okay, that's your submission. Okay, now we also have Ebenezer Nyakun.
And so I also think that you knowing it without the practical knowledge of it is also something, because if you have the knowledge about something, you should be able to solve problems. You should be able to create something out of the knowledge you know. That is what I think.
Okay, interesting. So you are trying to say that what justifies a programmer is not the fact that he or she knows the language, all right, but the fact that Joshua, okay, Joshua, go. Before
Yeah. Some example, an example. Someone is not aware, but can learn the aware language. The best it doesn't mean the person is aware.
Wow, Joshua's for the
Perfect
Mate.
scenario. Thank you.
Thank you, Joshua.
I think Joshua is really taking the words out.
Yeah, you are welcome.
I don't think there's any further or better explanation to what Joshua has done. All right, so it can be that the person knows the language, but is not able to really put it into action. All right, if it tell me that what is my name, and I tell you that my name is intelligent, and you ask me if I'm intelligent, what do you think what do you think will be the answer I give you?
That doesn't mean maybe you are intelligent. Maybe
So
that's your name.
my name is intelligent, and you ask me, am I intelligent?
Maybe in your your brain. What?
What do you think will be the answer I'll provide for you?
You are intelligent.
Yes, I'm intelligent.
Yes, I'm intelligent. You see, so that does not really require me being an intelligent person. All right. So we all understand the fact that a programming language, all right, is used by programmers, all right, to communicate directions to the computer, all right. So unless you make use of this programming language to have a communication with the computer, please don't call yourself a programmer. Okay.
Yeah.
All right. So thank you, Joshua. Your submission was killer. Kill everything. All right. So
Yeah, thank you, boss.
Okay, now I think that was my last question, but I would really love to ask another one though. But I want to give the opportunity for questions as well from your end, if you have any question to ask me. Ebenezer Nyakun.
Please, I want to know, do we have classification or maybe categories of programmers?
Yes, please, we do.
Junior and senior.
Oh yeah. She is right in a sense of she has actually given the names given to the title. Right, we have a junior what do we call it? Frontline programmer. We have a senior frontline programmer. We have a junior back-end programmer. So all these particular programming languages and what they do, all right, have ranks. All right. As I am talking to you now, even the program I program inside was programmed by somebody, and I can't compare myself to that individual. I can't really compare myself to that individual. Do you understand what I'm saying? All right. So there are ranks in programming. All right. So Ebenezer Nyakun, I hope I've been able to answer your question. All right, so I hope that one is well understood. So before I take any other question, please, I hope because it is the reason I'm stressing on this is because I'm not going to slow down for anybody when we meet again to do the practical aspect of this. I won't slow down to tell I've no set up my. That's why I am pleading with you now that if any of you haven't accomplished the goal of setting up your environment, please reach out. Vida, you're laughing. Please reach out. Enoch. Reach out and
Yeah,
then let's.
because I haven't set up my environment. So
You see what I'm talking about? You see, Enoch, get you.
Yeah,
Okay. Okay. All right. And then I think there's another hand to up.
hello.
Yes, please.
Yeah, this is Enoch. Yeah, I wanted to know if there is anybody here using MacBook, and then if the person has been able to install the C++ compiler.
See, so all these things are needed. Charlie, guys, reach out to each other. All right, let's help.
no,
Because
so
next
you
time
use code block. Code block will work on MacBook.
Oh, okay.
answers are coming. All right. I can't pronounce your name. Is it Kensel? I don't know if I'm right. Please, Kensel Samuel. Please, a question. I've allowed your mic.
Yeah, it's Kensha.
All right.
My problem is I put blocks a lot more than the C plus plus. My PC ran out into a problem, so I changed it and I try installing it again on the new PC. But everything is successfully installed. But then, if I try creating the new um, workspace for C++, it's giving me error and some things I don't understand it. Meanwhile, I have the other need to W and stuff, but I don't know the reason why it's giving me that error.
Okay,
I
so you can
want to
pick up
find
my
out.
number. You can really pick up my number and then send me screenshots of what you are seeing on your machine. Let me see if I can really assist you behind. Okay, I hope that one is okay for you.
Sure. Please can I get your number?
Yeah, I mean, all groups. I'm literally in every group. Freeman. In case you have seen something like Freeman Tech Solutions, that is me.
Sure.
But,
Okay.
so you can just go there and chat Freeman Tech. Type Freeman Tech Solutions. You see and just chat me. All right. And then Richard.
Freeman.
Yes, please. What did I do?
Yeah, please. So the first guy that asks if you can download the Dev C++ on MacBook. If the code block is not working, he can try C Lion. That one day to surely work.
Nice. Wow, interesting. All right, thank you, Vida. So please,
I'll
Welcome.
give him a contact so that he reaches out to someone who uses MacBook, so that
Okay.
maybe the person will.
Okay. Thank you.
Yeah, that's what I'm talking about. C Lion. So that one is to work.
Okay.
It works on both.
All right. Richard. Okay, Richard is gone. So I think at this point I will allow one of my coordinators to take over. There's an announcement he wants to deliver to all of us here. So let's welcome Dako. Dako, please can you hear me?